In this video, we are going to discuss about base first search algorithm, and I think this video we are going to discuss all the important points related to base first search, which are very important for your upcoming exam. So we'll start with base first search algorithm. The first point is that it comes under the informed search technique. That means, in case of the informed search technique, we already uh, know about the present state only. We do not have how much far I am from the starting node to the goal node, or I do not have the information about the costing from starting node to goal node. So this type of information we can get from base first search algorithm, which belongs to informed search algorithm. So informed search algorithm is under the technique of heuristics. So heuristics means it always provides the probabilistic path and how much cost it will take to reach from starting node to goal node. It will provide it to us. Okay, so first of all, we will start with the algorithm. Let open be a priority queue containing the initial state over here. First of all, you have to concentrate on open and close. Over here, what is written priority queue? Open is my priority queue, in which what uh, we have to do like normal queue. But what is the priority over here? Here, over here, based on their heuristic value. According to the heuristic value of the node, we are giving them priority. And according to that only, we'll remove them from queue. And according to that only, we'll explore them further. So over here, loop, if open is empty run the failure. Otherwise, remove the first node from the open, that is called a node. If node state is goal, then return the path from initial to node, else generate all the successor of the node. By seeing it looks like a theoretical concept. And if we'll solve this with an example, then you will come to know clearly that how actually BFS work. So over here, you are given a graph, you are given a graph. It is the map of, suppose a map of a city. Suppose a map of a city. Now over here, I want to reach from A to G. Suppose I want to reach from A to G. So A is my start state and G is my goal state. What is this? This is my goal state. Now to reach from A to G, first of all, as I told you, what does base first search use? Heuristics. Now over here, which heuristics method we are using? How we were calculating heuristics to calculate what? To calculate that we are using straight line. So the straight line distance, what are doing with the help of straight line distance, that is also called Euclidean distance, that we are finding out with Euclidean distance. We are finding out straight line distance from A to G, from D to G, from all the nodes. What is the Euclidean distance? What is the straight line distance? What we have found out, and that we have already written over here. So that is the straight line distance between A to G is 40, B to G is 32, C to G is 25, D to G is 35, E to G is 19, F to G is 17, H to G is 10, and G to G is 0. Why G to G is 0? Because G is a goal node. So I already mentioned here that if if the goal node is a starting node, then stop the algorithm because the both nodes are the same. So that's why the path value G to G is 0. Okay. The equilibrium distance, the straight line distance is already given over here. So we have to consider it is heuristics value. So on basic of heuristics value only, we have to work on base search algorithm. Over here, you can see the distance 7, 14, 25. These are not heuristic. This is the cost. That means the cost to go from A to C, cost to go from B to E, cost to go from E to H. It is not a heuristic value. Okay. So this is actually giving cost base for search totally concentrate on what? On heuristics value. You remember this point in base first search, we are concentrated only on what we have to keep main focus only on heuristics value. So according to these values, only you have to run this algorithm. So first of all, open a priority queue containing in the initial state. So what is there with me in open? That is A, because A is the starting node. So A came first of all next loop. If open is empty, then return and failure. Now we have nodes somewhere A is there first of all in open. So remove the first node, whichever first node. I have I have so by default A is the first node. So I have given node to it. I have given it a name node. If node is goal, is this my goal state? No, my goal state is G. So what I have to do? I have to come in the is part. In the is part. Because A is a not my goal node. So if A is a goal node, then return the path from initial to node. Otherwise, is part. So in the is part, simply over here, generate all the successor of node and put newly generated a node in open according to their fn values. What is the fn values over here? That is heuristics value. That is heuristics value. I already mentioned here. So fn is the heuristics value. So we have to put them in the queue according to the heuristic value. We have to remove it on the basis of their priority. So what is the concept of priority? Whose heuristic value is minimum? That is the best The concept is very simple. What is the meaning of heuristics? Somewhere you will calculate a distance or you find out the cost, the one which has the minimum cost, the one which has the minimum distance. That is best for me. So come, we will start from A and see who all the connected from A, B is connected, C is connected, D is connected. So you can simplify C over here from A, B, C, D are connected. The first of all, find out their heuristics value. You don't have to focus on this. You have to focus on heuristics value, not cost of the path. Then C, you are going from A to B. B will take you to the goal state. What is the meaning of this? That you go from C. What is the cost to go from B to G? That is 32, already written. Write down from A to C. C will take you the goal state with the cost of 25. D will take you to the go state with the cost of 35. So what you did, generate all the successor of the node, which is the node A, which is the node at this time. A put the newly generated node into the open, then add B, C, D in the queue. Then add B, C, D in the queue. Okay. But based on according to their heuristics value or Fn values, whatever you said that. So we know that the equation is Fn is equal to Hn. So open, then add BC. So A and put the newly generated node because A is the starting node which is added first, then it added BCD. Now A is open and BC in D in the queue. But based on according to their Fn values, that means Fn is equal to Gn. That means according to the Hn value, see according to the Hn value, if A was their first of all in the queue, I remove A out. Now, which one will go in queue? First of all, C will go. Why? Because cost of C is the minimum. Then B will go and then D will go. Simple. You have to work in very simple way. Now what you have to do, you have to again remove the first A is already removed. Now, which is the first one? C. So C is the first, then remove C, and then again we have to do some same work in loop. Then look, this both are already there in the memory. B and D are already there in the memory, but now we have to explore C. Based on the heuristic value, look, C is going at E and E and F, even though C again going to M, C possibility are there, E, F or A. Also, if you want to make, you can make it has no benefit, but still C connected with how many we have written with all. Now see, we are going to see to E and E is taking to the go state with 19 value, and F is taking to the goal state with 17 cost. So A is taking you to the goal state with 40 cost. So which is the minimum form of all of them? From all of them, F is minimum. So I am again telling you, you do not have to explore A. Yes, you will not do, because what we generally do, we have already explored A. So we generally add this into closed list. As we have made open, in the same way there is a closed. We have added them is closed queue, which have already been explored. So you mainly focus on E and F only, which is minimum from E and F. F. So now F will go first, then E will go. Because F is to be explored first, then you explore E. See, F is taking you. Is it taking you? Yes, F is taking you, me to G posted. And what is the cost to go from G to G? 0. Obviously, you have already reached at go state. Then go state will take you to go state with the cost of obviously 0. So over here, in this way, my path is being followed from A to C, from C to F, from F to G. So same we are doing over here. A to C, C to F, F to G. Also over here, my goal state has come. If open is empty, return failure. If remove open over, their node is goal. Now over here, G is my node. Then return path from initial to the node. Then what is my path? A from A. I want to go D. Sorry, from from A I went to C, a path that we have made over here. From A we had gone to C, C had gone to A from G, we had gone to G, the goal state. So see, this is my final path. So according to the heuristics value, it is taking me in minimum heuristic value till goal state. So generally in this way, base first search works. So look in uninformed. Now if we will compare this with uninformed or with without heuristics, so in that we use breadth first search or we use depth first search. So how that would have worked? From A first, it would have gone B, C, D. It have would explore all the three first. Then it go to the next level. In this, we have just explored C. We have say B and D. In case if it will go ahead and fail, then can again go on B. But still, we have not explored, and after that, look at C. When we reach at C, then it is taking at E also and F also, then I did not explore E. But if we use this in without heuristic or in uninformed, then on next level you have to follow each node of each level, which we generally do in BFS search. So that's why its cost, or generally what is the space complexity. We know that the place complexity or time complexity is equal to order of the b to the power d. Okay. Bit to D, that is B is the branching factor, how many children are there, how many nodes are being generated, and D is the depth, which is exponential time complexity. But the base for search, it generally works on greedy method. Over here we are using kind of greedy method only we are greedy for the heuristic value. I am greedy for the less heuristic value. I will consider it as my local maximum and I will explore that only. I will not explore the others. Then obviously my time complexity over here is good. But always remember that whenever you see base first search with heuristics, it always gives the good solution. It may or may not give optimal solution. There is no guarantee of it. It can give also, it might not give also. Yes, it will always give good solution. And you can normally say in best case, um, you can normally say in best case, mm, uh, in best case or in average case, it is much better than the ununiform method. It has exponential time complexity, it has exponential space complexity, but over here normal complexity will be there. Over here polynomial time complexity will be there. But always remember in all cases BFS also same order of b to the power b. It can go. That depends on what on heuristics. If your heuristics is good, if you have a calculated heuristics properly, then it is good. But if your heuristic is bad, then it can make you follow the same like uninformed, which is exponential time complexity. It is the same way like if you are roaming a new city and you want to go from one place to another, and you do not have any Google map or anything, then obviously what you will do? Obviously, you will use heuristics. What is the meaning of heuristic? You will take information, you will ask someone. If that person tells you correctly, then it is good normally. Instead of exploring the whole city, you will ask and go, then you will reach quickly. But if the person tells you wrong, then obviously what will happen? That is bad heuristic. Then you will require that much time only, which is required in uninformed or without heuristic. So in worst case, both are same, but you can say in normal case, in average case, in or in best case, it perform much better than the ununiform heuristics method. So see over here also, if you check just at the cost, if you are working on heuristics, then you are following this path A to C, C to F, F to G, that you look carefully. If you consider normal cost, just the cost to reach there, then see how much it is without heuristics. 14 plus 10 la that is 24, 24 plus 10, that is 44. So that means you reach A to G at the cost of the 44. But if you go through this A to C, from C to E, from E to H, and from H to G, then see what will be the cost. That is the cost of 14 plus 8 plus 9 plus 10. That means your cost will be how much? 41, which is less than the cost of, which is less than. So this cost, so if you take care of both this, that is cost also and heuristic also, then there are more chances to get optimal solution, which is generally used by A star, which will already get into the next video I will discuss. Thank you.